Hi, this video we're going to look at some trigonometry, basic concept and example in engineering and physics. So quick review on trigonometry. If I have this special scenario of triangle, it's right triangle. Let's call it ABC. And the big letter means the angle, and the small letter, that opposite to the angle, is going to mean the side length. So if it is a right triangle, the trig function for that is, for example, sine A of this angle is going to be opposite A over hypotenuse C, right? And then how about cosine A is going to be adjacent, which is B over hypotenuse C. Then tangent of A is going to be opposite over adjacent. So that's for right triangle. Also in right triangle, we have this Pythagorean theorem, c squared equal to a squared plus b squared. Of course, all the angle add up together is going to be 180 degree. Okay, now let's look at the general triangle. For example, I have something like that, which means there's no right triangle there. I call this ABC. Same thing for the side length. And then we're going to use law of cosine that's applied for every single triangle. And that means c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, then this can be extrapolated to be some other side also. B squared equal to a squared plus c squared minus 2ac cosine b, etc. As a matter of fact, here I'm going to look at a special situation. For example, if my angle C here is 90 degrees, if this is a right triangle, because you said this is universal, apply for every single triangle. And of course, you're going to apply for right triangle too. So what is cosine 90 degrees? 0. In that situation, plug it in. We have c squared equal to a squared plus b squared minus 0. And that is indeed our Pythagorean theorem, right? Okay, so law of cosine applies for everything. Now, how about law of sine? Law of sine is going to be equal to a over sine A, then this over sine of that angle, b over sine B, equals c over sine C. Same thing, look at a special scenario. If this angle C is 90 degrees, what's our sine 90 degrees? 1. So if that's the situation, plug that in. This is going to be equal to 1. Then our A is just going to be sine A equals C. So our sine A will be equal to A over C, which is the same as here. That's for the trig function for the right triangle. That's pretty much it. That's what I'm going to review for trig. Now let's look at some example you're going to use for engineering concept here. Now let's look at this one. There's a crankshaft and a connecting rod and a piston. So there's a piston right here and there's a connecting rod. Then I want you to determine the distance this piston travels as the position of the crankshaft is given. The angle here used to be 35 and then final becomes 30 degrees. So if I'm going to call this initial state, state 1, theta here is 35 degrees, and then when theta becomes 90 degrees, this is O, that's a fixed, that's not going to move. A is going to be moved over here, and the piston is going to be at a new position. That's going to be a B. And potentially, let me put A prime and B prime, that means a new position. They want you to know like how much this piston travel, right? The piston travel from right here and potentially gets to right here. So if I were overlay those two triangles, so that's how much this piston travel. That's the distance we're trying to calculate. Now how do we do that? This distance, this B prime, is going to be equal to initial AB minus AB, it's not AB, it's O, this letter is O. OB prime minus OB minus OB prime. That's the distance to travel. That gives us a sense of purpose. How do we do this? We just need to figure out OB and OB prime. Now, how do we find OB? So in this triangle, OAB, do we know two sides and we know one angle? And this angle is not the angle between those two sides. So we cannot use law of cosine just yet. However, we can find using law of sine, right? Then potentially we can find, when we find law of sine, then we can use law of cosine. I guess that's our direction we're going. So first step is this OB, that's the length, right? And we don't know that angle. It's sine A, the angle that's opposite to OB right here. That's going to be, so here I put an angle on the top, which is fine. You just make it consistent on both left and right hand equation. Here I'm going to sine theta. And here for the side length, actually we cannot do this yet because sine theta then times what? 300. And we cannot solve this yet. I'm just going to continue to write it. And then we're going to know this 120 corresponding to this angle, right? Sine B. And the theta here is 35 degrees. So knowing those two, I can find our angle B. So that's what I would do. So cross multiply 120 times sine 35, then divide by 300. Then take an inverse sine. The angle I have is, so I have this angle is 13.26 degrees, right? The way we solved it is sine B times 300 equals 120 times sine 35, cross multiply, right? Okay, so we find this angle B, knowing that we can find the angle A, because angle A will be 180 degrees, this angle right here, minus 13.26 degrees and minus 35 degrees. Let's see what we have here. So I have angle A, 131.74 degrees. So knowing this angle, then that can help us trying to find, let me erase that. Then that we can use cosine law again to figure out OB. Using the cosine law, OB squared is equal to, so I'm going to take a square root, is going to be equal to 120 squared plus 300 squared minus 120 times 300, and times the angle between them, which is angle A, cosine 131.174. Then we get the third side length, which is OB. Let's take a look what we have. So the calculator gives us 390.3 millimeter. That's our OB. Going back, remember we need to find OB. So now we just need to find OB prime, right? OB prime is going to be right here, and this is 90 degrees, so it's right triangle. We can use Pythagorean Theorem directly. 300 squared minus 120 squared. And let's see what we have. So I have answer as 274.95 millimeter. That's for our OB prime. Then how much this piston has traveled, basically it's from B to B prime. And that's going to be OB minus OB prime. 390.3 minus 274.95. The answer I have is 115.35 millimeter. All right, that's how much this piston has traveled. All right, so that's a quick trigonometry problem. Now let's look at another example. I just have a Pythagorean parallelogram here, and let's see if they labeled as A, B, C, D. And they said this is 3 meter, this is 6 meter. The angle between them is 50 degrees. They wanted to find BD, the diagonal BD distance. Also, the longer diagonal AC. We're not going to solve it, just kind of like point out the direction. How do we figure out BD? BD, we can just taking out ABD, right? I'm isolate A, B, D. This is 3, this is 6, this is 50 degrees. In order to find a BD, it's going to be direct application of Cosine Law. 3 squared plus 6 squared minus 2 times 3 times 6 times cosine 50. All right. Now how about AC? Then I'm going to take out the top triangle ABC. AB is 3 meter. And how about BC? So parallelogram, AD going to have the same as BC, so that's going to be 6 meter. And how about this angle B here? If this angle is 50 for parallelogram, this is 50. This two angle add together gonna be 180. So that's characteristic of the parallelogram. So that would be 130. Knowing that, we can quickly figure out AC, right? Using cosine law again, 3 squared plus 6 squared minus 2 times 3 times 6 times cosine 130. All right, that's all I have for this trigonometry quick review and some of the problems you might see for physics and engineering. All right, see you next time. Bye.